Hello students, welcome to this session. In the previous two lectures, we have derived the mirror formula, we have also derived the expression for the linear magnification. Now let's make use of mirror formula and the expression for linear magnification, which is m equals to h2 by h1 is equal to minus v by v. But before proceeding with numericals, there are certain formulas which you should be aware of, right? So let's start with the relation between U, F and M. M is the linear magnification, right? So in certain numericals where the image distance is not given and out of these three, two are given, then the value of the third one can be easily determined by the formula which we are going to prove, right? So we are aware of it. M is equal to minus V by U. We have done it, right? Also, as per the mirror formula, 1 by V plus 1 by U is equal to 1 by F. No doubt regarding this. Now in order to obtain a relationship between U, F and M, what to do is multiply throughout by U. Multiply throughout. Throughout means on both the sides by U. So look at this one. On solving, what we get is U by V plus 1 is equal to U by F, or U by V is equal to U by F minus 1. So taking LCM we get U minus F by F, isn't it? Taking reciprocal, U by V is this one. So taking reciprocal we get V by U will be equal to F divided by U minus F. Now linear magnification is minus V by U. So minus V by U would be equal to F over F minus U. In order to obtain this negative sign, I will interchange this term. And what about minus V by U? It's equal to linear magnification, isn't it? So linear magnification in terms of F and U would be F divided by F minus U. So this is an important formula. So there is the relationship between the linear magnification, object distance and the focal length. Similarly, you can proceed with the relationship between V, F and M. V is the image distance, F focal length and M is the linear magnification. Again, as for mirror formula, we are aware 1 by V plus 1 by U is equal to 1 by F. Now what to do is multiply both sides of this equation throughout by V. Now keep on solving V by V, that is 1 plus V by U is equal to V by F, or V by U is equal to V by F minus 1, which implies that V by U would be equal to V minus F by F. Now linear magnification is minus V by U. So if you put here as negative sign, then these two terms will need to get interchanged. So minus V by U is the linear magnification denoted by small letter m. So m would be equal to F minus V divided by F. This is another important formula. So why I am telling you these formulas is that in order to solve numericals, certain steps can be avoided, right? Time management is very important in solving numericals. So even if U is not given and out of these three any two are given, then the third one can be easily found by using this particular formula. And here I must mention that in numericals you need to make use of sign convention. If it is the case of a concave mirror, F is to be taken as negative. If it is the case of inverted image, linear magnification is to be taken as negative. If the image is real, again V is negative. If image is virtual, V is positive. You need to remember all those facts, right? So, after dealing with the relationship between MUF and MVF. So let's start with some very basic questions, right? Let's start with very basic questions. Let's consider, students, please listen to the question very carefully, right? Let us consider an object of size 10 centimeter to be placed in front of a concave mirror of radius of curvature maybe 40 centimeter. At a distance of 25 centimeter from the concave mirror. Okay, again I am repeating the question. Please listen to it carefully, right? The question is, an object of size 10 centimeter is placed in front of a concave mirror, converging mirror of radius of curvature 40 centimeter at a distance of 25 centimeter from the mirror. You are supposed to find the nature, position, size of the image and linear magnification. So these are the 4 parts which we will try to solve. So again I am repeating the question. An object of size 10 centimeter is placed in front of a concave mirror of radius of curvature 40 centimeter at a distance of 25 centimeter from the concave mirror, right? Find the nature, position and size of the image and also determine the linear magnification. So students, how to proceed with such questions? So what you do is, make use of this sign convention. That's of utmost importance, right? So we are aware of these 2 formulas. These are the 2 formulas which are to be used. 1 by V plus 1 by U equals to 1 by F. That's the mirror formula. And linear magnification, it is ratio of the size of the image to the size of the object, and it is equal to, in terms of image and object distance, it is equal to minus V by U. So these are the 2 formulas to be used, isn't it? So what you do is, size, this is the size of the object. Object is always placed erect, so it is to be assigned positive sign. Sign convention is must. H2, it is to be determined, right? R. Now look, radius of curvature for concave mirror, I have told you, it is always negative. So it is minus 40. Focal length, it is R by 2. So it will be equal to minus 20 centimeter. Focal length of a concave mirror is always negative. So it's very important, the sign convention. Okay. Object distance, it's always negative. So it is minus 25 centimeter. Actually, even without doing a single step, you can easily identify the nature of the image simply by recalling all those 6 ray diagrams in the case of concave mirror, right? You can draw a rough ray diagram as well, right? This is the mirror, concave mirror. T, this is F, this is C. Now the focal length is 20 centimeter, this is 20. Radius of curvature is 40. Object is placed at a distance of 25 centimeter. The object must be placed somewhere over here. This is the object, isn't it? So we are aware, when the object is placed in F and C, then what happens? Its enlarged inverted image is formed beyond C. So nature of the image can be easily predicted without doing a single step. What will be the nature of the image? It will be real and inverted. It will be magnified. It will be formed beyond C. So the image distance and magnitude must be greater than 40. So these all are the information which you can collect only through your theoretical knowledge. We have not done a single mathematical step. So this is what I mean. The theoretical portion should be crystal clear. I mean, all the ray diagrams should be imprinted in your brain, isn't it? So let's deal with it mathematically now. Substitute these values. Out of these three, if two are known, the third can be easily determined. So let's solve it. 1 by V plus 1 by U is minus 25. It is equal to 1 by focal length is negative, that is minus 20. We can easily solve it. 1 by V it will be equal to 1 by 25 minus 1 by 20. It is equal to, LCM can be considered, suppose it's 100. So 4 minus 25. So 1 by V is equal to minus 1 by 100. Or V equals to minus 100 centimeter. Minus means the nature of the image is real. Look, I've told you, image is found beyond C, greater than 40 centimeter. This is the answer. So we have discussed the nature, the position. Image is found beyond C at a distance of 100 centimeter from the pole. Negative sign suggests that the nature of the image is real. Right? Now regarding the size, how to determine the size? Look, H2 by H1 is equal to minus V by U. We all are aware of it. H2 is to be determined. What is H1? It's given to be 10. What is V? It's minus 100. What is U? U is minus 25. So H2 by 10 is equal to plus, so it is minus 4. So H2 is equal to minus 40. That's in centimeter. So we have already discussed its image is larger in size, magnified. So the size of the image is greater than the size of the object. So it comes to be 40 centimeter. Negative sign suggests that the image is inverted. Right? Now linear magnification. Linear magnification. It is basically H2 by H1 or minus V by U. H2 is found to be minus 40. H1 is equal to 10 plus 10. So M is equal to minus 4. Look, I have already told you, in case the nature of the image is inverted, linear magnification should be negative. You can tally your theoretical knowledge with the mathematical result obtained. If they correlate each other, then the answer would be perfect. So you can cross-check your answer basically. So minus sign indicates that the image obtained is inverted. 4 indicates that the size of the image is 4 times the size of the object. That's linear magnification. I hope you have understood this numerical. This is the correct way of doing numericals based on mirror formula. Right? Let us discuss some other questions as well. Right? Let us assume it's again a question based on your theoretical knowledge. Let us assume an object of size, this is the second numerical we are doing, 5 centimeter, be placed at a distance of 20 centimeter in front of a concave mirror of focal length 10 centimeter. Okay, again I am repeating the question. An object of size 5 centimeter is placed at a distance of 20 centimeter in front of a concave mirror of focal length 10 centimeter. Find the size of the image, the position of the image, the linear magnification, and state the nature of the image so obtained. So, what's the thing which are given to us? Size of the image. Actually, size of the object, that is H1, it's given to be 5. Object is always placed erect, so plus 5. Object distance, it is given to be 20 centimeter. Object distance is always negative. It's measured from the pole against the direction of the incident ray, so it is to be taken as always negative. What else is given? Focal length. Of a concave mirror, converging mirror, it's always negative. Clear? This is given. Let's see whether this question can be solved without doing any mathematical step or not. So let's try to make use of a theoretical knowledge, right? So let's draw a rough diagram. This pole, the center of curvature, midpoint, that's focus. Focal length is 10 centimeter. So radius of curvature would be 20 centimeter. Isn't it? So object is placed at 20 centimeter. So object is placed exactly at C. This is the point to be noted. Object is placed exactly at C. Right? Object is placed at a distance of 20 centimeter. 20 centimeter is also equal to the radius of curvature. So this is the case where the object is placed at a distance of 20 centimeter, that is at the center of curvature of the concave mirror. Now students, do you remember? Whenever object is placed at C, then its image is also formed exactly at C. In this case, the size of the image would be exactly equal to the size of the object. The image obtained would be inverted. It will be real, formed on the same side as that of the object. So if this is the object, in the same position, image will be formed. You have done it. So what should be the answer? Size of the image should be same. So H2, it must be equal to also 5 centimeter, but it should be inverted. So this will be the answer, size of the image. What should be the position? It is real, formed at the same point C. So it should be 20 centimeter. What should be the linear magnification? It is H2 by H1 and inverted, same size. So 1 with negative sign. So these are the answers which we can obtain without doing a single mathematical step, just by using our theoretical knowledge. So I have told you always, simply concentrate on those 6-7 ray diagrams. They should be crystal clear. The rules for the formation of image, then the nature of the image formed in different positions, that should be crystal clear to you. And I assure you, any numerical, you will be confident to solve it. Right? Okay, these are the answers. We have already obtained the answer. But let's verify mathematically as well. So what to do is, 1 by V plus 1 by U is minus 20, 1 by F, that is minus 10. So let's solve it. So it will be 1 by 20 minus 1 by 10. LCM would be 20. So it is minus 1 by 20, or V would be equal to minus 20 centimeters. See? You have come across the same result. Isn't it? Okay. Now M is equal to H2 by H1 is equal to minus V by U. H2 is to be found. H1 is given to be 5. V is given to be minus 20. U is given to be minus 20. Minus 20 get cancelled. So H2 is equal to minus 5 centimeter. See? Size of the image is same as that of the size of the object. Negative sign suggests that the image obtained is inverted. Linear magnification, it is H2 by H1. H2 is minus 5. H1 is plus 5. So it is equal to minus 1. So minus sign indicates that it is inverted. 1 indicates that the size of the image is same as that of the size of the object. So look, mathematically also, we obtain the same result as was obtained theoretically. So, I hope now it appears to be very, very simple, these numericals. Please do all the numericals given in your NCERT textbook, as well as try to do some additional questions based on mirror formula, right? Let's consider the case of a convex mirror. Let's do one more numerical based on convex mirror. An object of size 2 centimeter, an object of size 2 centimeter is placed at a distance of 20 centimeter in front of a convex mirror, of radius of curvature 50 centimeter. Find the nature of the image, determine its position, determine the size of the image, and also find out the linear magnification. Again students, let's make use of our theoretical knowledge. This is a convex mirror. This is center of curvature. This is pole, midpoint is the focus. Now look, radius of curvature is 50. So focal length is r by 2. So it will be 25 centimeter. So this is 25 centimeter. Object distance is 20. So object is placed somewhere over here. And object is to be placed in front. This is 20 centimeter. Now look students, in case of convex mirror, the image is always obtained behind the mirror, wherever might be the position of the object. Image is always formed behind the mirror. So image is always virtual and erect. So nature of the image we are already aware. In case of convex mirror, it should be always virtual and erect. So nature of the image should be always virtual and erect. And it is formed always between P and F. Over here, image will be formed, right? And you are aware its size is less than that of the size of the object. So H2 in magnitude must be less than H1. Or linear magnification must be less than 1. This also we are aware. And image is formed between P and F. So we have obtained all the results. So what would be the value of V? V would be less than 25 centimeter. The image distance should be less than 25 centimeter. Right? So let's now do it mathematically. Let's see whether the answer which we have obtained theoretically is in agreement with the mathematical obtained result or not. Right? So, first and foremost, object size H1. Object is always placed erect, so +2. Object distance, it is always negative. Incident ray is traveling along this direction. PB is measured in the opposite direction, so it is negative, -20 centimeter. Focal length, 25 centimeter. Now look, PF, it is measured along the direction of the incident ray. So that is what I told you. Always remember, the focal length or radius of curvature of a convex mirror is always positive. So it is +25 centimeter. Let's make use of the mirror formula. So 1 by V plus 1 by -20 is equal to 1 by 25. Let's solve it. It will be equal to 1 by 25 plus 1 by 20. So it should be equal to 100 can be taken as LCM. 4 plus 5. Isn't it? So it will be equal to 9 by 100. So V would be equal to 100 by 9. So it is equal to, right, with positive sign. Look, what's the focal length? 25. What is the distance of the image from the core of the mirror? 11.11. So what I mean to say is that image will be formed between P and F. So it tallies with the theoretical obtained result, isn't it? So plus sign indicates that the image is obtained behind the mirror. That is, the image is virtual, which is always the case in case of convex mirror, right? So image distance is obtained. Now let's try to find out the size of the image, which should be less than this, which should be less than 2 centimeter. Let's see. M is equal to H2 by H1 is equal to minus V by V. H2 is to be determined. What is H1? It's +2. Minus, what is V? V is 100 by 9. What is U? It's -20. So you can solve it. Minus minus, it will become positive. So H2 by 2, it will be equal to 100 divided by 180. So H2 would be equal to 200 divided by 180. So it will be equal to 10 by 9. So 1.11 centimeter. Is it clear? So look, the size of the image is obtained to be less than that of the size of the object. So image is diminished in size. So obviously linear magnification would be less than 1. So always remember, whenever a numerical is based on a convex mirror, the nature of the image is always virtual, erect, diminished, and linear magnification will be always less than 1. You can calculate the value of small n. It will be positive and it will be less than 1. H2 by H1. So value of H2 is 1.11 divided by H1 is 2. So that will be positive value and less than 1. So linear magnification is H2 by H1. So H2 is about 1.11 and H1 is 2. So it is positive and less than 1. Linear magnification less than 1 means that the size of the image is less than the size of the object. I hope students you have understood the application of mirror formula in solving such numericals, right? Please do practice as much numericals as you can, right? Numericals, as I've always stated, it's an integral part of physics. So practice more and more numericals. Then only you can gain in confidence. Well, all the best then. Try as much numericals as possible. We'll continue in the next session.